Imagine you are tasked with managing a massive, crowded zoo, but there is a catch. All the lights are permanently turned off. You hear a sudden rustle in the dark. You have absolutely no way of knowing if that sound is just a zebra sleeping in its pen, or if a highly dangerous tarantula has escaped its cage. Modern software applications operate exactly like this invisible zoo. They run entirely out of sight, executing millions of tasks every second on computers halfway across the world. Because developers cannot physically watch their code execute in real time, they have to build specialized sensory systems just to understand the baseline reality of their own digital world. To see how we build these eyes, we're looking at a project called the Bug Zoo Simulator. It is a digital environment built in two distinct halves. The first half is the simulation itself. Here, automated animals generate random actions, eating, sleeping, or escaping in the background. The second half is the ticket counter. This front office is where people ask for status updates on specific animals. Under the hood, this entire facility is built using a digital building engine to run the logic and a secure record keeper to write down every event that happens inside the enclosures. But having a ticket counter and a record book is useless if the staff has no reliable way to see what's happening in the pens before a visitor starts asking questions. To fix our dark zoo problem, we use a concept called observability. It's essentially the practice of installing high-tech digital sensors at every single gate and feeding trough in the facility. We start by creating a permanent paper trail for everything that happens, but these aren't just normal notes. If a human zookeeper wrote down an event, it might be a messy, scribbled note. But for a computer to help us, it needs information in a strict, color-coded grid, where every piece of data, like the time, the animal, and the danger level, has its own specific labeled home. This creates something like an airplane's black box recorder. It's an indestructible record of the past that we can search through in seconds to see exactly when a specific gate was opened. By organizing our records this way, we remove the guesswork. Every single animal action is recorded in a universal language that machines can read for us during a crisis. But even with a perfect record book, you can't spend your whole day reading every single entry. Sometimes you just need to know if the zoo is safe at a single glance. That's why we also use digital summaries, snapshots of the zoo's health that update in real time. If our detailed records are like a mechanic's multi-page report, these summaries are like the speedometer on your dashboard. They don't tell you the history of the engine, they just tell you how fast you're moving right now. In our zoo, we use a digital gauge that counts every alert as it happens. We don't need to know the name of every animal to see that the needle is suddenly spiking into the red. These summaries act as our early warning system. They tell us when a massive problem is occurring, long before we have to dive into the records to find out why. But what happens when the zoo gets popular? If hundreds of visitors hit the ticket counter at the exact same time, and the entire system abruptly crashes, how do you find the one person who caused the glitch? To solve this, we give every single visitor a unique digital barcode as soon as they walk through the door. It's just like a barcode tag on a piece of airport luggage. Every time that bag moves through a security checkpoint or onto a plane, that tag is scanned and recorded. As a visitor's request moves from the ticket counter into the animal habitats and down into the record books, it leaves a stamp of its barcode at every single stop. That barcode is automatically attached to every single record created during that visitor's stay. This eliminates the frustration of untangling a crowd. By scanning for one specific barcode, we can isolate exactly which visitor's action caused a cage to rattle. To ensure these sensors work everywhere, we wrap the entire zoo in a digital shipping container. This ensures that the environment runs exactly the same way on any computer in the world. Now, let's look at the actual payoff of this system. A tarantula has just escaped its enclosure in the dark. Instantly, our dashboard gauge spikes red, signaling a danger surge. Our perfectly organized records instantly show an error entry with the exact escape time. Scanning the attached barcode points directly to the visitor request that triggered the latch. This transition from guessing in the dark to seeing the light makes modern software reliable. When you can monitor thousands of moving parts with this kind of clarity, you can catch problems before they ever affect a real person. Without these sensors, developers are flying blind. If you want to see